Okay. Um, what we've looked at so far are electrochemical cells or galvanic cells, and these relate to the spontaneous reactions between two half cells, one where oxidation is taking place and one where reduction is taking place. Now, this produces a voltage, a flow of electrons between the two half cells, um, and as I said, the reactions are spontaneous. Now, it's also possible to actually supply a voltage, which is supplying electrons, to force the two spontaneous reactions to actually go back in the opposite direction. And you've already seen this with commercial cells, particularly with the lead acid battery, where when you recharge the battery, you're forcing the two reactions that are taking place in the half cells to go back in the opposite direction, and then the commercial cell will then, when you remove that and you connect them to an external circuit, the reactions will take place in the spontaneous direction again. So electrolysis is a process by which you can obtain substances which are difficult to obtain by any other means. So things like aluminium, things like sodium, all of the alkali metals essentially, which are very strong reductants. You can actually force those reactions back in the non-spontaneous direction to obtain usually the pure metal. Now this process is called electrolysis, and electrolysis essentially means the splitting of a compound using electricity. So lysis means loosening or setting free, and you can read that splitting, and electro obviously means electricity. So it's sometimes also referred to as electro-winning, because you win the metal back from a compound. So you can use electrolysis as a means of obtaining things which are difficult to obtain by chemical means. So let's have a look at a cell. Now you'll notice a few differences between an electrolytic cell and a galvanic cell. In an electrolytic cell, you can see we've got two electrodes, but they're actually in the same pot. For the purposes of WACE, what you need to know is essentially the splitting of binary salts. Now, there's a little bit of a grey area, and the grey area is aqueous solutions, and I'll probably deal with those in the round in another lesson. So you can see here on the electrolytic cell we've got a source of electrons, in other words our battery. This is essentially just a potential difference. So some things that students typically get wrong with electrolytic cells: the battery symbol here, the longer line that you can see on the diagram here is the positive, and the shorter line is the negative. And it's important to get these the right way round, because if you then subsequently say that something's produced at this electrode and it's the wrong polarity, then your answer will be wrong. So that's kind of the first thing to note. You can see that it's all in one pot, and typically what happens is you take a compound. In this case I've used sodium chloride as my example, and you need to free up the ions. So it's important that you actually are aware that because you want the ions to flow, they need to be free to move. So typically how that's done is by melting the substance, in this case sodium chloride. Now I think this is animated, so we'll go through this and we'll see what happens. The battery is going to supply an electron. That electron is going to move down into the cathode, and what's going to happen is it's going to attract positive ions towards it, because the cathode in an electrolytic cell is electron rich. So that's going to attract these ions, the positive ions, in this case the sodium. They're going to pick up electrons and they're going to become sodium. Similarly, the anode here is going to be electron poor, so it's going to have a positive charge, and so that's going to attract the negative ions. What's going to happen there is we're going to drop off some electrons and they're going to complete the circuit, and then we're going to end up with Cl2, chlorine gas, here. And that's essentially an electrolytic cell with a binary salt. So these are the reactions that are happening. The anode, in the case of an electrolytic cell, is positively charged. Now that's different. That's the opposite of in a galvanic cell. So the two chloride ions, they produce chlorine gas and 2 electrons. And then at the cathode, which is electron rich, the sodium is going to go to those, it's going to pick up an electron and it's going to produce sodium. So, in summary, the ionic solids have to be molten, or they can be in an aqueous solution, and this allows the ions to be able to move, and it allows the flow of charge actually in the cell. The anions go to the anode, the cations go to the cathode. So the positively charged ions, they will go to the cathode because that's negatively charged, and the negatively charged anions will go to the anode because the anode is positively charged. Here's my little aid memoir again. So reduction occurs at the cathode, red cat, and at the anode oxidation occurs. Okay, so anox. So this is the oxidation process, so that's happening at the anode, and this is the reduction process, gaining electrons, and that's happening at the cathode. And that's pretty much electrolysis or electrowinning.